This is sections 11.6 and 11.7. We're going to talk about the volume of pyramids and cones. So starting with a pyramid, the volume will be the area of the base times the height divided by 3. So it's like a prism, but we're dividing by 3 now. You'll notice the height is going to be from that common point straight down to the center of the base. There's an L on the side here that actually stands for slant height. We're not going to use it for the volume. That's actually used for surface area. So for example, 1A, it says state the type of pyramid shown and then find the volume. So this is a triangular pyramid, which means the base is a triangle. So when I'm setting up B and H, we're going to do this triangle, 1/2 base times height, 1/2, 4 times 6, which is 12. And the height, the up and down, was 9. So my volume, which is BH over 3, would be 12 times 9 over 3. And we could do this all at once. And I get a volume of 36, my units were meters, cubed. For example, 1B, this would be a rectangular pyramid. So my base, which is the rectangle, would be 21 times 9, which is 189. My height is 5. That's how tall it is from the center of the base to that common point. So now we can do 189 times 5, all divided by 3. So my volume here is 315 cubic yards. So here's 2 for you to try. You can pause. The answers are posted on Google Classroom. For example 2, we want to find the height of the pyramid. They're giving me the volume is 14 cubic feet. We know the base is a triangle that has a height of 3 and a base of 4. So we know that we could find B. We know V. And I'm looking for H. So B would be 1/2 times 4 times 3, which is 6. My height was unknown. My volume was 14. So if V equals BH over 3, then 14 equals 6H over 3. I can reduce 6 over 3. If I wasn't able to, I would instead multiply both sides by 3, which was what I'll do just to show you that we can do it that way. So this is going to be 42 equals 6H. Divide both sides by 6, so H is 7. And the units were feet. So here's a check-in for you to try. Pause. Answers are posted on Google Classroom. For example 3, Caitlin is building a sandcastle in the form of a square pyramid. She bought 3 bags, each containing 1,200 cubic inches of sand. Will she have enough to build the castle? So we're going to find the volume of this square pyramid, and we're going to compare it to her 3 bags of sand, if she has enough. So we know the base is 25 by 25, which is 625. The height, right, standing up, is 18. So my volume would be 625 times 18 divided by 3. So she needs 3,750 cubic inches of sand. 3 bags, each with 1,200, means she has 3,600 cubic inches of sand. So she needs more than she has. So will she have enough to build the castle? No. And then there's a lot of ways we can answer this. She needs 3,750 and only has 3,600. No, she will be short by 150 cubic inches. That's what I'll say. T will be short by 150 inches cubed. So there's one here for you to try. Pause. Answers are posted on Google Classroom. Cone is the same as when we took a prism to become a pyramid. We took the formula for prism and divided it by 3. So cone and cylinder are similar in that we're going to take the formula for cylinder and divide it by 3. So that's going to be pi r squared h over 3. Once again, this L here is irrelevant to us. That's meant for surface area. So example 4a, we're going to find the volume of the cone. We do see we have a radius of 9, and we have a height of 17. So when I do pi r squared times h over 3, you can do this all at once. I tend to write it as two separate things. I write the top first. So I do my 9 squared times 17 times pi, and I got 4325.97, and that's still over 3. You do not have to do this. You can certainly go straight to your final answer. So we're going to say 1442 yards cubed. Example 4b, I'm not given the radius this time, and my height is going sideways. So my height is 8, and my diameter was 5, meaning my radius is only 2.5. So we're going to have pi 2.5 squared times 8 all over 3. So I have 157.08 over 3. So my volume would be 52.4 inches cubed. So there's 2 here for you to try. You can pause. Answers are posted on Google Classroom. Example 5. A jeweler is making earrings in the shape of cones out of gold. Each earring has a radius of 2 centimeters and a height of 3 centimeters. If gold has a density of 19.3 grams per cubic centimeter, find the mass of a pair of earrings. So I want mass, which is really equal to density times volume. I know the density, I don't know the volume. So let's start by finding volume. Said it was cones, so that's pi r squared h over 3. The r was 2, the h was 3. So for one earring has a volume of 12.57 cubic centimeters, and a pair of earrings would be 2 earrings. So if I double this, I'm going to get 25.13 cubic centimeters. So my volume now is 25.13. My density from before was 19.3. So mass is density times volume. So I get about 485 grams. So check in here for you to try. Pause. Answers are posted on Google Classroom. Example 6, a builder has constructed concrete pyramids to put on top of a fence post. They each have a mass of 110.4 grams. Concrete has a density of 2.3 grams per cubic centimeter. If the base of the pyramid is a 4 centimeter by 4 centimeter square, what is the height of the pyramid? So we are given mass and we are given density. So the only thing we didn't know there was the volume. And volume is equal to mass over density. So we will start by finding our volume. So mass was 110.4. Density was 2.3 grams per cubic centimeter. So if I divide 110.4 by 2.3, I get 48 cubic centimeters. So now I know my concrete pyramid has a volume of 48 cubic centimeters. The base was a 4 centimeter by 4 centimeter square. So the area of that would be 4 by 4 or 16. And again, we don't know what the height is. So if volume equals BH over 3, then 48 equals 16 times H over 3. 16 over H doesn't work, so we're definitely going to want to multiply by 3 on both sides. So 144 equals 16H. And when I divide by 16, I get 9, and I believe this was centimeters. So the last one for you to try is right here. Answers are posted on Google Classroom. And that is the end of sections 11.6 and 11.7.